Cool. I'm going to briefly share my screen and just kind of talk about where we are in the workshop process. So today we're presenting in 3 groups of 3, hopefully having discussion after each of the groups. So for part 1, we've spent a lot of time on research for the various infrastructure systems that students were interested in, how they might overlay with the city or react to the city and the constraints associated with those. We've been having presentations every day where the students have a chance to share their research. We can talk through where those numbers come from and maybe what might be missing. That led into technical diagramming of these systems as a way to kind of visually express how the system works and connects. It's almost as if this is a one-line drawing from engineering or a version of an architectural drawing for an infrastructure system. These are still in progress, of course, because as we learn more about the systems, these will become more complex, I'm assuming. Then we got to take all of those constraints, data, research, and start building our own data sets for each of our projects and learning how to use CycleGAN. So all of these images are from the samples folder of each of the students' CycleGAN model. They're all running and training their own, which has been exciting and also very frustrating for the students, as I'm sure you'll hear today. And so while we kind of just started playing with CycleGAN, so we do have some initial images of what the site might start to mutate into, but these are very much in progress. Because of the different infrastructure systems and because we all have goals about what we want to get, I know that these will continue to change throughout the rest of the workshop. These are all student generated as well, so they're starting to look cool. And then what's going to happen after this crit, not today, but tomorrow, is we're going to start overlaying the intelligent agents with those research constraints on top of the site. So that's still to come. But great. So should we start with first group? Park, you're up.
Yeah, I'll share my screen. Can everyone see my presentation?
Yep.
Okay. Hi, I'm Park Jung-wook, and I'm going to present the work I've done till now on Unit3. First of all, the reason I came up with infrastructure related to waste is because after COVID-19, the overall amount of waste increased dramatically. So I thought it'd be cool to start with infrastructure about waste. And of this infrastructure, I focused more on MRF, which stands for Material Recovery Facility. MRF is the facility that sorts all the waste into different categories like cardboard, paper, glass, metals, and plastics here. What I felt interesting about this facility, especially in case of Korea, is that Korea is one of the few countries that waste plastic the most. But people don't seem to take it seriously, as they tend to think that plastics can all be recycled. The thing is, according to Greenpeace, only about 20% of the plastics are recycled. Indeed, recycled indeed. So what I came up with after I wrapped up all this information is upcycling. That is to upcycle the recycled plastics into reusable packagings and replace the disposable packagings to reusable ones. So if you see the diagram here, it shows how disposable packagings turn into reusable ones. At first, restaurants deliver their food using disposable packagings, and people in their house receive it, eat the food, and dispose the waste. Then it goes to MRF, and this facility sorts on recyclable plastics and recyclable plastics. The recyclable ones are then moved to the manufacturing companies and turn into reusable packagings. Then these packagings go to the restaurants, and the restaurants can use them instead of disposable ones. This time, when restaurant delivers food with reusable packagings, people eat the food and let the drivers take the packagings. Then the drivers take it to the wash stations, and those packagings are washed to be reused. After that, they can again go to a restaurant to be used again. And the consumers can choose whether they may receive the food with reusable packagings from the app. The reason for this is because using reusable ones could be burdensome as consumers have to return the reusable packagings after they finish eating. The last images show how reusable packagings are used. Send the packagings to the restaurants use them, then the driver retrieves the packagings, and those packagings are washed to be reused. To talk about CycleGAN, I chose the satellite image of London. The reason for choosing London is because I thought that there seem to be many parks in the city, whether it's big or small. So I thought if this trait is learned and mapped on our side of Seoul by using machine learning, many green areas could be made in that map. Then I thought I would just translate those green areas into MRS, manufacturing companies for producing reusable packagings, and the wash stations. The image on the right side, on the top right side, are the results of CycleGAN. I first got this image and wanted the map to have more green areas and got the result at the bottom. And here's the progress that I've done till now. And thank you for listening.
Awesome. Dal, you're up.
Oh, yes. Okay, I start my presentation. The biggest problem with our future is global warming. Therefore, we need to dramatically reduce carbon emission. Despite the increasing amount of clean energy generation, we cannot meet our energy demand in the future. So I suggest SMR can be the solution. SMR can provide electricity from nuclear resources and then reuse the remaining heat for the heating and cooling around area, and also can also be used desalination. This plant can make a lot of money, and then we can get another nuclear resources from that, and also use to dispose the waste and reconstruct another plant for the future. In the future, using SMR, I suggest installing this plant in our city and reconstruct our city shape around this SMR, because the energy demand our city in the future will be continue grow. This energy-centric urban form will be consist in many places in the future. Our current structure is grid shape, and our future city shape will be energy-centric shape. Uh, this continuous energy-centric city shape will be constructed in many places in line with the increasing demand for carbon-free energy. So we were trying to find how can we make our future city shape using machine learning, and yes, we were trying right now. Yes, I'm done. Thank you.
Okay, great. Saw you earlier. Saw you right there. You're up. Is your Vienna?
I'll do it. Hi everyone. This time I thought about wastewater recycling system. So when we think about the future of city, we have many problems such as climate change and energy crisis, waste problems. To solve this problem, I proposed the system as a based system of water and energy cycle of Seoul. As you can see this image, Han River accounts for the large portion of Seoul, and it is really important water source. Seoul has 4 sewage treatment centers, and it provides clean water to around 10 millions of people living in Seoul. But the problem is the rate of reusing wastewater is only about 15%, even though it is one of the most abundant water sources of Seoul. Because Seoul has weak renewable energy sources due to its geographical limitations and it doesn't have enough available land, the use of wastewater resources is really essential. So to optimize the amount of recycling wastewater and save energy, the factors on this image can be solutions. Water treatment plants in Seoul now is based on mechanical plants consuming steel and electricity, but it can be changed into more natural way using water-based treatment facilities and treating method by bacteria. Also sludge, which is a byproduct of wastewater treating process and makes odor in the city, should be used more actively as a part of energy resources. Because previous sludge treatment process includes a lot of mechanical steps such as a water treatment process, it also can be changed into eco-friendly way. For the last, the treated and untreated water can be used as a means to transfer heat to apartment complexes or public facilities, which help to reduce carbon emission and heat island phenomena. So this is the diagram showing the entire process of the system. Wasted water is sent to the water treatment center here from the consumer through the Korea Works Corporation. And the wasted water is sent to the treatment center and it is treated and it's sent to the final stage of disinfection. So it is recycled back to the consumers again. In this process, Korea Waterworks Corporation connects them and makes ways for water to transfer heat. The yellow one shows how sludge is treated and recycled to biosolid for renewable energy in treatment plants. And this is the site area and the image that I use for Cyclogen. And this is the purpose. I wanted to make the water-based wastewater treatment plant in the middle of Han River, since there is not much of available land in Seoul right now. And I wanted to make the image, including area connected by waterworks from Han River. And this is the image that I'm in the progress of making and kind of showing the future image of Seoul that I wanted to apply the systems that I explained so far. Thank you.
Great. So, well, we've tried to group them in terms of like related projects. I feel like the first group is applying an infrastructure system within the existing city without trying to manipulate it so much. But I'm not sure if each of the infrastructure systems is clear or anything.
Hi, my
First,
name is Woo Hyuk Choi. I make
did we want to, so originally the plan was to talk after each of the groups? So like we would talk after group one, or should we just go through all of them and talk at the end of it?
No, I think we'd better have some discussions maybe so
Yeah,
that people
okay,
can
so-
understand better.
Well, yeah, so just give us like, you'll present in like 5 minutes, okay?
yes. I make a presentation about borrow them.
Well, yeah,
Oh.
what,
Can you unshare your screen?
We're
우혁
gonna talk
씨,
about
첫
group one.
첫 번째 그룹 디스커션 먼저 하고 두 번째 그룹 시작할게요.
Can we have some images up? Maybe Laura, do you have maybe their key images?
I can
Or-
grab them. I don't have them readily available.
Oh,
but
okay.
in the meantime, Park, do you want to share your screen about the and your diagram?
Okay.
And can you talk a little bit about the pairing of manufacturing next to MRF and the benefit of that, or your idea about that?
Okay, so since MRF is the facility that stores the different waste into different categories like cardboard, glass, or plastic like that, and especially in Korea, the plastic waste is like they consume a lot of plastics, so we have so much plastic waste. But the problem is only 20% of the plastic is recycled indeed. So what I thought was using this plastic and upcycle it to the reusable packagings, and we use it instead of the disposable packagings like the something that we get when we order food and get from delivery, and we use it instead of disposable ones to the reusable ones. Then I thought in the end the overall waste of plastic may reduce as people would use the reusable packagings instead of the disposable ones.
So it's pairing a recycling plant with a manufacturing plant together and having multiples of those throughout the city that connect into a wider transportation system, as well as like food delivery system and recycling system.
Can I have a question?
Yes.
So it seems on this diagram, it seems kind of linear process, but
Yes.
I can imagine this as a sort of loop, right?
Yes. Okay.
Did I understand in the right way?
Then I think it'd be better to show this image. So if I understood right, your question is you don't understand how this system may work in real. Is it right?
You know, I was asking the terminal point of the diagram, which is 3 houses,
Yes. Yes.
is
Okay.
the same houses of it. Yeah, if it can go on the upper part, then going into the cycle again.
Oh, I'm sorry. Could you say what you said just before again? I didn't understand. So you mean the house?
Yeah, those houses in the red box,
Yes.
which is the terminal point of this diagram. The ending
Yes.
point of this diagram can
Yes.
be the same target of the upper part, the upper 3 houses.
Yeah. It's better to think of this diagram on the top side as the before, and the diagram on the bottom as the after. I mean, at first we start from the disposable one, not the reusable things. So like before, if the recycling system was like linear, not the circular, like it started from disposal packaging to the waste, but here after using the reusable ones, like it goes circular. So restaurants, house wash stations, restaurant, house wash stations, restaurant, house wash station.
Okay.
So if I understood correctly, what you're showing above is the existing system that we are recycling the plastic waste, and then below ones are the one that you're proposing, which is the reusing plastic waste.
Yeah,
And then you're making the system over the urban fabric.
So like before, if we had to just like dispose the like on recycled plastics, and like there wasn't many ways to use the recycled plastics, and especially these days since oil prices are plummeted, like there's no demand for these recycled ones. So I'm proposing to just upcycle it to the packaging and like make a new circular like system so that no disposable packagings are used anymore.
Yeah, it's like basically looking at how to transition an existing system to a new system in combination with how those might work in the future, with an understanding that no system will just be switched from one to another. There will be a period in between where you would have to move between or have both in combination. So
Yeah, I think all these are really super interesting proposals. And from a point of view that I'm not an expert of these environment issues or everything, I don't know in conventionally in reality, maybe in engineering world, or I don't know what is a conventional way of researching this. And I don't know if these diagrams are downloaded ones or their own productions. And I would love to also learn what is the a bit more like conventional ways of doing it and how you hacked it and like changed it. So I want to see if there's any comparison that we can learn from it and so on. Yeah, so I think they are all pretty new to me, and I think they are really interesting. I don't know how the researchers are researching on this, and I'm sure there is a very specific science about like learning these systems of disposing and recycling, and that there must be some terminologies that you are using here is also a conventional one. So yeah, it will be very, very helpful or handier for the audiences to understand what is already existing and what is something new that you hacked into. Yeah, and especially for students, maybe it's all new for you, so you might be very difficult to distinguish that. But it's very important for you to really distinguish in your presentation. And I think I saw a lot of images and references you are using are downloaded ones, and you have to indicate the resources because otherwise it's plagiarism, right? I'm sure like you didn't do it purposefully, but it's really important that in your any publication or any lecture presentation, you really indicate what is your own work.
Okay.
Yeah, this is for everybody. It happens to every time. So yeah, just to remind everybody.
So
in general, everyone is showing all of these technical diagrams are done by them. As far as where the research comes from, especially within the first slide or two, I mean, maybe Case can talk about what he was going through at tutorials for research, but a lot of it is looking at what exists now, looking for specifically if that system exists within Seoul and how that currently works. a lot of those systems then lead us to how the systems are being stressed in terms of like too much waste, not enough power, and then like the way we intervene is like solving one of those problems. So like the problem that Park was looking at was specifically in terms of plastic waste. There's a lot of it that isn't being used, just sent to landfills. There's not enough landfill space. What can we do with that? How could we reintroduce that? Dahl was looking at there's not enough power generation within the city, especially with projected numbers for the future. How could we increase the number of power or like the amount of power throughout the city more evenly dispersed? And then Yana was looking at cleaning water systems specifically for sewage using a more natural process and getting energy back from that. So hers is kind of a double. Let's take sewage water, let's clean it via a natural process or more natural process, which is better for the environment, thereby giving us, you know, cleaner water, but then also being able to generate waste heat and energy from that process that could feed back into the grid.
Yeah. Yeah, I think they are all valid and really interesting topic. Yeah. And it's really good that they invented all these diagrams to illustrate these problems and system. I think that's awesome. And maybe I'm just because I don't know this much, so I'm not expert. So that's why I want to know where are these informations are actually coming from? Is there any literature review on this? And yeah, I'm sure you didn't invent every single thing, because if you did invent everything, it's also not very believable. Yeah, so it's good that you build up on somebody's knowledge and show your intervention from there. Yeah, so yeah, just very curious, where is it in the state of art currently?
Actually, I first started with collecting like statistics data from like Seoul City.
Yeah, I'm sure. Yeah.
Some articles from like Greenpeace, and I got most of the information from the YouTubes. I saw many like videos relating to the trash waste, or like in case of the system of cycling, these reusable packagings. I also saw the company that who really does this kind of things in YouTube. So I like got some source from them, how it is done, how they are working, and I got the reference from those companies to make this diagram.
Mm-hmm. Okay.
And in case of the like sources, I got these two images and these three images from the internet, and these ones from the internet, and others are made by myself, but I'm sorry that I didn't put on the exact source. Yes.
And maybe the further question is how this is going to be fit into the technical application, right? So the CycleGAN images are super cool, yeah, and really looking forward how this can connect to your proposal. I guess that's coming in the after midterm.
Yeah, so I think what happens is they develop a process through a world building process where they kind of take an existing technology and they speculate out just out of their mind, out of what they've learned. Then, you know, you take the CycleGAN and you make a modification to the city. In Park's case, he was discussing like what would happen if you put manufacturing facilities in concert with the recycling facilities. So it's not a radical idea in terms of two radical technologies that don't exist. It's just taking those things and putting them in geospatial proximity to each other to reduce, energy in relationship to transportation and energy, and streamlining waste recycling process. So the first order of business is to get the CycleGAN, and then from there it's you just kind of select a site somewhere else that has the kind of conditions that you think might exist around this proposed combination of manufacturing and recycling. The next step with the intelligent agent system will be to articulate how the circulation of these drivers works inside a bounded area related to the facility. So if you think about it, it's kind of like, why move all this trash multiple places? Why have drivers moving around when they don't have any load? So he's created a system where hopefully through an app-based incentive, he might be able to close the loop on a particular portion of trash related directly to food delivery. So he's basically taking all the systems that exist and stringing them together in a new way, and then giving them a geospatial representation through the CycleGAN, and then animating those drivers as intelligent agents to kind of explore what it might look like to have you know, hyper segmented nodes of delivery, much in the way delivery apps work now. You know, if you want to order from a restaurant that's outside of your delivery area, you know, no, good luck. In this instance, delivery and recycling and manufacturing all exist inside an area that's bounded by a geofence related to an existing technology. So, you know, I think it's actually kind of an interesting idea. I was sort of like, that's a pretty good idea. You know, it'll take a little while to fully articulate it, but I think that's what he's going for. And that's how it should wrap in to the technological processes presented in as the technical portion of the workshop. So we kind of get an idea down and start to see how it works out in relationship to you know, the C# intelligent agents and the CycleGAN, which, as we all know, never plays exactly, never does exactly what you think it'll do, which is kind of part of the process as well.
Can I ask some questions regarding the method that you just described? So if I understand it correctly, kind of a new method of recycling, or like any kind of what is it, topic is kind of thought out by students, and then that is so after students come up with new systems, right, and using kind of like superimposing existing images that they think already employ that system onto the desired site, and kind of start really designing from there, right? Is that what they're trying to do?
You want to go, Laura? Should I?
Yeah, yes. So it's like looking at an existing system, building
Right.
upon that system in a way that interests them and is pretty heavily influenced by a narrative. And then it's on the side looking at how to work CycleGAN and just becoming familiar with actually using these machine learning processes, which is a beast of its own.
Mhm.
And then it's trying to force the CycleGAN to do something that relates closely to their narrative of the site.
Right.
So that's where we are right now, is trying to kind of rectify the idea, the system, and the CycleGAN. And then, yes, the next step will be through that CycleGAN image, overlaying information that would connect it back to the grid and help explain better how the system works. But we're like halfway between that part right now.
Yeah.
So.
I mean, it just seems like a lot, right? Because you're coming up with
It's a super complicated. Yeah.
It's I mean, it's crazy because you have to come up with, you do all kinds of research, and you're almost at the mercy of this this machine learning thing, because I mean, from what we did in our unit, which is completely different because it's Stargate, right? It never does what you think it might do or what you want it to do. So Yeah, it's and I think it's really interesting how almost that, I mean, as I think Case talked about before, how that randomization in the process can kind of trigger a generative process. It's quite cool. And that almost gives students new kind of unexpected scenarios to work with. I think that's really interesting.
Yeah, you know, because when we talk about mutation, I mean, you know, it's if the process was wholly predictable, it really wouldn't be a mutation, would it? I mean, it would be,
yeah.
you know, and so, you know, part of the way it's structured is having to react at every stage of the process, just like any design would to a true mutation, right? Like you're constantly having to reconcile the research, the tools, and your narrative. I mean, it's very narrative based. It's essentially world building, you know, just kind of speculate, you know, with a small research base. And in a lot of ways, to me, this is very reflective of how, you know, as someone who does work with engineers all the time, how engineering, you know, proceeds. Like you're constantly being, whether it's economic, technical, political constraints that are, you know, so we've kind of recreated that process. And part of the lesson is really learning how to accept and reconcile yourself inside those tools, you know, and to get an introduction to those tools and understand that they are, you know, they're beasts, you know, and that's part of the fun. You know, we don't expect them to have a fully realized, perfectly articulated, app-based, you know, recycling program, but just the notion. Yeah, but the notion that you could follow an idea all the way through with these tools and recognize the complicated nature of the process alone, I feel is really valuable for people who want to get involved in machine learning. You're like, okay, well, here's the process, you know, like here it is. And we've given you a story, you know, you get to tell a story and you get to tell that story with these tools and hopefully, you know, it's rewarding and at least in like, maybe now Yana knows a lot about sludge, you know, like there's a lot to know about sludge out there in the world. All right, so I think we need to move on.
Yeah. Thank you.
Okay, group 2, we're gonna start with Seth, you ready?
Are we not gonna, we're not gonna talk about the other 2 students' work? I know the first one is always the longer one so that we can understand the unit brief, but maybe even if it's very brief, maybe.
Okay, so give us 1 second. So do we have comments about, should we go through Dal and then Yana very quickly?
Yes, please.
Dal, can you share your screen really quick?
얘는 두 번째, 세 번째 학생이 누구셨죠?
I thought we were using Jongwook's one as a representation of the 3. Yeah.
No. Was it?
Yeah.
I mean,
yeah, it was a group.
It's really like, you know, getting our ideas.
Okay, that's fine then. Yeah.
But whatever you guys want to do.
Yeah, let's move on. Yeah, I think otherwise it's gonna be too long. Yeah, but maybe it will be great to have a final image with all 3 key image from all 3 students in one image. Yeah.
Yeah, that'd be great.
When we discuss, yeah.
If I had planned ahead better, I would have done that. But I'll get it. Okay, so now you can present.
Should I share my screen now?
Yes, please. Thank you.
So, well, my name is Jang-min Seok, and I will talk to you about the SMR disaster and the incident response plan for them. So, a reference from the master plan for future energy use in Korea. So their goal is to drastically decreasing the greenhouse gas and not using the full energy. So additionally, and they are planning to shut down most of the nuclear power plant in 2040. So what I thought is that we should use the small modular reactor for the future. So, so for the efficient distribution of electricity, so I tend to locate the SMR on the center of the Seoul. So what I thought next was how to defend the SMR. So, so for the defense system, I reference from the traditional called 직성충. So this is to minimize the defense point, which is that only have to depends on the entrance. So the similar image that I got is from the Brøndby city on Denmark. Looks like this. And for the plan of the arranging SMR in the Seoul, I plan to use this structure, and since the SMR uses tons of waters per day, so I try to irrigate the water from the Han River. So what I did first was I want to get a idea from the cyclic image. This is the image that is learned from the Brøndby city, and it's learned by to the site. So what I can see is its shape become like a great cluster of great. So I got an idea from this image. So this is the incidents I tend to respond. First, on the left one is the response when the leak, the flood comes, and the right one is the instance when there's a leakage on the SMR. So first one, for the flood, they will first control the water from the dam, and the villagers will evacuate from the river as far as they can, and this new location will get alternative energy from other SMR, and as this promises the sufficient amount of energy, the location in this SMR will shut down the electricity to the village. And next, for the reaction to the leak, since they will first shut down the dam for more leakage, and since the hazardous matter will go further, by the order of distance, the village will evacuate in the order of distance. So they will relocate it in the outer side, and they will make a new village. So this is what I got from now on. And for the future plan, I will elaborate the graph more precisely by the time order, and I will apply it to the actual site. Thank you for listening.
Thank you. Next, finally.
Hi, my name is Woo-hyuk Choi. I make a presentation about Boro Dam. Look at the chart on the left. You can see the average rainfall and annual precipitation. In Korea, rainfall is regionally and seasonally best, so floods and droughts are frequent. In order to manage the water dam needed, because about 65% of the country is mountainous and has unfavorable natural conditions for water resources. management. Look at the diagram on the right. Water is managed by K-Water. This is the integrated water resources management. It refers to the integrated and intelligent management of water quantity, water quality, aquatic ecology, and environment, which were managed individually. In consideration of everything that affects water management in the region in order to manage water optimally. This is a case of flooding in the Han River last summer. This picture shows a view of Han River Park in front of Olympic Boulevard. To solve this problem, I suggest Morning Glory Spillway and underground dam. Morning Glory Spillway is applied when there is a space constraint on the installation of a spillway, or when it's difficult to install a spillway of a different type due to topography and geology. The underground dam is used to store water underground. Look at the technical diagram. When the flood begins, the water level will rise, and then Morning Glory Spillway will suck the water. The water moves to aquifer and hydro power plant. Aquifer will store water, and hydro power plant will generate electricity. And these sources are delivered to homes or factories through substation. Jamsu Bridge was selected as the site. It was built in 1976, but has been rocked every year for the past 45 years, except 5 years. When the water levels of the Han River exceed 6.5 meters, the bridge is submerged. To reach this level, 7,000 tons of water per second must be continuously discharged for 7 to 8 hours. If it exceeds 5.5 meters, pedestrians and bicycles are restricted, and if it exceeds 6.2 meters, vehicle traffic is restricted. Highest water level is 13.7 meters. This is a cycle gain test image. Although it's not perfect yet, machine learning was performed to create a circular shape in the Han River part. This is future solving river flooding by sucking water through various levels, and the ground is used as a park section plan programs for water management and hydroelectric power plants. Thank you.
Great, thank you. And then Gil.
I focus on the infrastructure problem in Seoul. Currently, the landfill in the Seoul metropolitan area is located in Incheon City. However, the Incheon City declared that it would not accept waste from the metropolitan area from 2025. Seoul City faced the problem of finding new landfill. The diagram shows that the waste disposal process. Diagrams show that no matter what the process is, waste need to be buried in most cases. Therefore, landfills are essential. Seoul Metropolitan Government has held landfill selection contests twice, but local governments do not want to accept the city's garbage. So landfill is the problem that needs to be solved in Seoul. However, the Seoul City land price continue to rise and it's hard to find site for landfill. So I thought of making an island with landfill in the Hangang River and using it. However, if the island continue to build, the Hangang River will be full of island. Therefore, it seeks to create sustainable, reusable landfills. We cannot suddenly create the island. It needs soil or ash from incineration. So the landfill would be better located nearby incineration facility. I decided site near Nanjido, which was previously used as a landfill. Now it is used as park. develop Nanjido as a sustainable landfill. This is sustainable and reusable landfill process. The stabilization period usually takes about 20 years. And after all process, it can be reused as a landfill. Landfill do not cover waste during the stabilization period. While one landfill is period of stabilization, another landfill covers the waste. In this way, several landfills can be used alternatively. I use the image on the right to make an island in the Hangang River on the left image. So the result came out like the left image. And I combined result and original image like this. For the rest of the workshop, I will have more visualization of the project. Thank you.
Here's my thrown together free project.
Thank you. That's very helpful. Thank you.
I think it is very interesting to see new different the environmental solution using the GAN technology, and then all the groups has their own idea like how to understand the current state of the environmental issue, and then its solution with some of the circular infinite loop, such as like creating new the environmental cycle. And then I feel like from the technical points of view, I think you are trying to extract some of the infrastructure system from the target city and then map it onto the soul, which have some of the environmental problems. But I think you are extracting it from the last stage, even though your planning city, Seoul, in your case, is in the initial stage. So what I wanted to just suggest for the future, but I'm not sure also it's gonna be work, but what about gathering some the target cities images in different time frames, such as like 1950 or 1960, 1970, that show the development of the such infrastructure system, and then run the cycle again to extract the progress of that the infrastructure development. I'm not sure it's gonna be work, but yeah.
No, I think that introducing the idea of time into at least some of these projects makes a lot of sense. And we've floated the idea to a few of the groups that are looking at certain things that in looking at it over time, you would get a better picture of where it would be going or why we're even looking at it in this way, especially in relation to the ones with water and dams, because that changes so drastically. So no, we've definitely been thinking about that.
Yeah, sure. I can imagine it. Yeah.
I think it's because like when we look at these three projects, they have such different, they all have different agents, different things that will be moving through the process, but they also have like very different discrete temporal boundaries. Like Gills takes place over like 50 years or 70 years. Yux is like takes place over what, 24 to 48 hours to clear the water, depending on how well that system works. SUPS is like, it takes place. The thing that I think is really interesting about this one in terms of evacuation routes, which is where he wants to go with it, it's like, it could take place over an hour. Like his entire system could all be based around 1 to 10 hours of evacuation process. Like each one is very discrete in its temporality, which is something we've been trying to work through in the diagram first as part of the narrative of the space, you know, like the story of how it works. Translating that into the CycleGAN, we have a couple animation ideas and some of the, you know, with image interpolation that we can use from still images through a couple other programs, but it's just going to be a push, you You know, hopefully we get at least one hero.
Yeah,
image
yeah,
out of it.
sure.
Well, I think what you're saying needs to be articulated inside the diagram. You know, like if Gills had a you know, if you were to put it, if you were to take the diagram not as a, you know, not as a technical, but as a narrative diagram of the of the work, you could add time there, and you'd be like, oh, I get it. This whole thing takes place over 5 hours, you know, or 300 years, depending on what kind of speculation the student wants to make.
On that, I think so. Like these are super technical diagrams, right, at the moment, and I just want to raise the issue of legibility because I saw quite a lot of diagrams until now, and you know, it's diagram making. It's an art, you know, with its own rights and I think, you know, I think it has to be clearer in terms of what it exactly wants to convey, because some of that, like, I mean, I mean, also because the presentations are quite short, it's quite hard to actually, you know, go through them and then really look at everything. And I'm just thinking if there's like a better way to really, like, you know, capture your attention. And I just want to add upon what Case just said. It'll be super interesting to kind of see how these, like, I mean, when the superimposition happens with cycle game, and when design process actually starts, how, you know, social politics and, you know, these kind of things can work as a driver, like a narrative driver to almost lead the project. Is when I heard about the waste management, right, like I immediately thought of, you know, politics, because they were trying to end, you know, the landfill by 2025, and, you know, like, what does that mean? I mean, it's a super important political gesture. It has its own narrative. I think it'd be really interesting to kind of set one specific way as a narrative pathway to develop the project as well, rather than trying to encompass the entire, like, a whole yeah, like possibilities, like different possibilities at once.
Yeah, I think that's a good point. I mean, we're working in tandem. I feel like in a lot of ways the narrative will become a lot clearer as the boundaries of the image making become more solidified. Like as you realize your capabilities, you start to be like, well, you know, I do think, you know, there's you know, some of them are like, yeah, I agree. Diagram making is a really fun tool, and yeah, building the narrative into it takes a little time, but I think we can get there, especially with some of the feedback we're getting right now, you know, like, and also honing in on just what exactly the agent is in this process. Like, what is the thing we're following? You know, in Sub's case, it's people evacuating from a disaster. In, you know, Hyuk's case, it's water, a specific type of water in a specific geofence, that, you know, a specific area. In Gil's case, it's 50 years of trash, you know, which may be which the metric may be like by the ton. So part of the initial research, which has been going, is just sort of like learning the language of that space, just being like, okay, what are, you know, what, so in, you know, Hyuk's case, it's like precipitation, like water, like how does water even work? Like how do we even measure this system? What are the metrics by which we start to engage with it, which is kind of a fun little discovery in its own right, I think. So we'll see how we can continue to sharpen the knife of the narrative as we move through to the end of the project.
I mean, the point you made about, you know, like understanding the almost like the geo image, right, of these systems are really interesting, because you know, that book with all these images from above of all different kind of like areas of the world. And yeah, I mean, super interesting. Thank you.
Yeah, we've definitely had some interesting discussions as well. I think, I hope that that we all find them interesting about the fact that we've chosen the satellite view and like what the implications of just this projection are. You know, because it's like a very, very specific way of viewing the city. It's a very, very specific observer, you know, which is in a lot of ways analogous to the tools that we're using, right? Like we're using computer vision, machine learning models, viewing it through a, you know, machine apparatus from an inhuman angle. And that, you know, is a fun way to like start to think about the implications of the technology as it relates, as it's a political question, even of itself, like even just the way we're doing it. We try to encourage that analysis as well as we move through the process, you know, because obviously there's some inherent political implications in machine learning in general, which is probably for another time, but you know.
Do we have any comments about projects, or should we move on to the third group? Third group it is. Okay, Ning, you're up.
Oh yeah. Hello. Can you hear me? Okay, great. I'll share my screen now, and you can see me here. Okay. So you can see the slides. Bar is here. No, it's not. It's just sorry, I'm gonna stop this. Yeah, now it's full screen. Here we go. So hello, everyone. My project is named Snail Stopper. So how big would a stopper be to stop the snail that's smaller than the green bean? My answer is the world's largest dam, the Three Gorges Dam, with its 660 kilometer long reservoir. The first step of this project happens in the scale of the dam. Then we'll scale down to the perspective of a single snail. Although I haven't really done that part yet, it's just a future scenario. So here shows the dam and the reservoir. That was well, the reservoir was the Three Gorges Nature Reserve, and the snail research happened here, the Dongting Lake, which is the downriver of the dam. And then the diagram shows, well, not only technical size, but also social and ecological part. And it shows the flow in the geographic direction horizontally from up to downriver. However, I'd like to find the junction. That's why I call this the junction, and the balance between the water control and its surrounding environmental impact. So the research and design process starts with urban development near the dam and with the satellite view. Then we're gonna zoom into the small creature, the snail itself. So here is, well, here's the timeless of Seoul's redevelopment and relocation with a dam. Yeah, and here's what I've got up to now. I will narrow down my focus to the snail's living condition in and near dam. And that's it. Thank you.
snails. Okay, great. Hyundai, you're next.
Hello, my name is Hyundai, and I choose wind power as my project concept. So, like, oh,
Is there a way
now
to share like in presentation mode? Like full screen?
oh,
If not, don't worry, but
like a few weeks ago, I actually traveled Jeju Island, and at that time, I rode a bicycle, and like I enjoyed this scenery a lot. There were many wind turbines along with coastal lines, so it was very fascinating. Yeah. So my project begin with like disadvantages of wind power. How can we solve like disadvantages of wind power? So these are some disadvantages of wind power. And mostly I just focus on this one thing. The first thing, the wind is inconsistent. Like every renewable energy is very inconsistent. For example, like solar power, like depend on weather condition, and also wind power is mostly depend on strong wind. So this renewable energy is very inconsistent. So sorry for Korean news articles. So if you search like some problem of wind power, then you can find that even though they invest a lot of like money in renewable energy, like it will be like many problems. So this diagram is like power system of Jeju Island, and there are this huge circle means three conventional energy generation plants, such as thermal power plants, and these small circles are wind powers, and yeah, and these three scales are called HVDC. So the amount of energy generation is varied depend on time. So when energy is needed, then it can be borrowed by the mainland. So the upper graph like can be explained like the problem as I said. So these four colors means conventional energy source. These are consistent. However, this green one and blue one is varied, depend on time. For example, during the daytime, maybe from 6 a.m. to 6 p.m., because of the solar power, like Jeju Island doesn't need like energy from the mainland. So I thought about how can we solve this problem. So I just found like green hydrogen. So maybe we can surplus or overproduce wind power energy as source for hydrogen energy. So we can store it as hydrogen energy. And next step, I made this cyclogram image. So so in the cyclogram energy, like I can confirm that there are a lot. Actually, at the time, I didn't have any idea how could I like process my project. So after I did machine learning process, I could find that maybe I can imagine like Jeju Island full of wind turbines. So it was very nice experience. So by using this cyclogram image, I could like imagine like future system of Jeju Island. So by using cyclogram imaging, I drew like imaginary sectional drawing of Jeju Island. So maybe this satellite image can be like typical spatial structure. Like if you be in Jeju Island, like there is beach and just next to the beach, there is coastal roadway, like surrounding Jeju Island. Yeah. So in this system, like I think hydrogen energy processing unit. Actually, I don't know about it. I don't know about it now. Many or like all of energy produced by wind power flow into this like kinds of hydrogen energy processing unit, and then it again like give many area like such as we can like propose like hydrogen charging stations for cars or boats. If you be in like Jeju Island, there are a lot of electrical car, but maybe we need a like kinds of paradigm change from electrical energy to hydrogen energy, especially in Jeju Island. So as well as we can use hydrogen energy for like agriculture or just common energy for urban area. So in the sometimes like wind turbines is recognized by people as visual pollution, but retrospect my memory, then when I traveled Jeju Island, for me, like wind turbine was quite beautiful. Like I think it could be like attractive for travelers and also picturesque. Yeah. So this is like view from this the view from this hotel or many other programs, maybe energy experience tour. So maybe next step like combine like concept of window. Maybe I can design like hotel considering like aerodynamic simulation like that. Yeah. Thank you very much.
Great, thank you. Carlos, are you here?
Yes. So can I go?
Yeah. Hannah, can you stop sharing?
Yeah. Sorry.
Okay. Okay, so my project is called Plastic Biorecycling Deltas. And the main share, can you see my screen?
Not yet.
No, not yet.
Oh, okay.
Maybe try to stop sharing and reshare.
Okay, yeah.
There you go.
Yeah, there might just be a lag.
Okay. So can you see my screen now?
Yes, your
Okay.
desktop, I think.
Yeah, I'll present like a. So my project is called Plastic Biorecycle Delta. The infrastructure that I focused on was the material recreation facilities, but instead of actually trying to improve these material recuperation facilities. The idea is to spread these facilities instead of them being concentrated in a few specific spots in a city. They would be distributed in several regional centers, and then after they have been collected in these centers, they would be and also classified. They would be sent to a specific area that would be large enough to receive a certain amount of waste from various areas, and then recycled the material. In my specific case, I decided to focus on plastic because, for example, South Korea is one of the top per capita users of plastic, and also it's one of the more highly rated countries for recycling. So there's already a good infrastructure in place, but also still a lot of use and problems regarding plastic. So what you can see in this conceptual image is that I would try to take elements from certain natural systems where certain organisms generate colonies that can be thought of as a representation of the organisms that transform in a sustainable way the plastic, and also maybe cities or places in the world that are as advanced or even more advanced than the infrastructure existing in Seoul. And if there is the possibility, perhaps also then influence other places in the world, such as Mexico City, that has a very, very big problem of waste management. So the overall scheme is to have in the orange circles, these represent the plastic transformation, the regional collection centers that agglutinate the waste, specifically the plastic waste from neighboring areas. And then from them, they would be tried to be transported via the modification of existing thoroughfares all the way through what I am referring to as plastic transformation centers or deltas. And the way this transportation would be made is by either subterranean canals or superficial canals, but the main focus is just to try to generate this these thoroughfares, these routes, and identifying where in the city these local centers would be, and make a connection between them, and try to make them arrive like a river delta to specific places where the recycling from algae and bacteria would take place. So as you can see, the A's are like individual buildings or smaller neighborhoods. The B's are the centers where the waste gets collected in the first place, and then they all go from their local centers to the delta, where you could have the bacteria pools or algal pools for plastic recycling or plastic generation of new algal plastic, and perhaps other, let's say, harder infrastructure such as laboratories, where there can be like trial areas or recycling through nanomaterials. So it's like a very speculative project about future technologies regarding recycling, specifically for plastic. Right now, I am still testing the cycle gun, but this is the opposing site, which is, or the B site. It's a place in Alaska called Prudhoe Bay. And I chose it because of the several things occurring in the same place, such as the deltas, the rivers that are more or less analogous to the routes that I would be wanting to be representing, and all the different pools that would be similar to the algal pools or the bacteria pools, and even these smaller areas could be thought of as the laboratories. So it's still training, and what I'd like to do after this training is to incorporate other images or data sets to the larger data set in order to specify more the idea. For example, maybe some recycling facilities that are very clear, where you can see the different buildings where the recycling happens, where you can get an idea of how the transportation takes place, and also perhaps ships that would try to translate the idea of the way the waste is collected and transported, and perhaps aesthetically something related to the abstract algal or bacteria images, such as this type of image. But first I wanted to try with just directly this site, because it already has a lot of info. So that's what I could present so far. Yeah, that's the end of my presentation.
Awesome. Thanks, Carlos. Let me share my hacked free together one. I think I'll also briefly just say that in grouping students together, I think these three really ran with the narrative side of the project in terms of, and like really decided to push it further outside of the site as well. So yeah.
Just for the second project, Hyundai's project, I think it's super interesting how section was incorporated, because I was thinking when I was like listening to previous presentations, how, because some of the, like a lot of these infrastructures are actually hidden. I think the one that comes to my mind is probably the postal tube network in London that existed, like they existed underneath the actual tube system, right? And I think that was used, during the war for shelters and stuff. And these kind of things are, usually beneath ground, could be beneath ground, and how these could be incorporated. So I think incorporating section was quite nice in a way. It was quite fresh to see. And I also had a question of, so like some of these systems are obviously quite periodical, because they don't run all the time. And wind powers and solar powers, they obviously run when wind exists and sunshine exists. And I think there could be an element there like that almost periodicness, I don't know, the temporality of the resource can be somewhat more visible in diagrams and ideas that develop afterwards. Yeah, that's my comment.
Yeah, I thought it was interesting. We had a couple discussions about it, and Hyundai was like, "I'm going all wind." You know, that was his proposition. To which, under normal circumstances, you might say, "Meh." But then in this instance, since it is like since that's sort of making a proposition that's a little bit problematic, is kind of part of the whole baked into the whole thing. I was like, okay, you want to go all wind? You know, like make it work, like figure out like how are you going to do that, you know, like. So then he was like, I'm going to do hydrogen, but we're storing hydrogen batteries. I was like, okay, how are the electric cars going to, like, how are those cars going to interface? Like, are you just going to make the Jeju Island its own, like, how, you know, I think we're still working through that idea. And in relationship to the underground systems, I totally agree. I think for ones that have those, that's where we hope to incorporate those intelligent agent systems. But somehow or another, the linearity of that will show, like, in some cases where we need to articulate where that, like where water is moving or where it could possibly move, and then, you know, speculate out from there. That I couldn't all win. All right, let's do it. You know, like, sounds good.
It's like a windmill colony almost.
That's where I was like, isn't this place known for tourism? Like, I was like, is that for its beautiful views? But, you know, I think that's the kind of thinking and the kind of world building that we sort of encourage, you know, not necessarily, it's not about being right or wrong. It's about thinking it through as much as you can, you know, as much as is available to you in the time, just being like, because, you know, I've seen some pretty wild proposals in my day, and you know, that's just the way it's going to be. I think especially when facing strange things like population increase, you know, food scarcity, you know, fossil fuel, you know, weaning off the grid, and all these things. It's like sometimes there's just wild ideas that get floated out there. One I saw the other day was growing from a very reputable engineer wanted to grow bricks on site from a bioengineered material that you would plant in the site after excavation, then it would grow the building blocks. And I was like, I mean, maybe, I don't know, but it's an interesting idea.
I mean, they're building stuff out of mycelium, is it? Like the fungi.
Mycelium, yeah.
Mycelium, yeah. It's like, okay.
Yeah, right.
Yeah, it's just I mean, that's just how it's going to be now.
I think we're in I think one of the reasons we kind of wanted to do this was we're in a very interesting time where the interconnectivity of systems, especially in relationship to data, is becoming such an important issue. You know, when we talk about like the mutation of a city, it's like these systems a lot of them are old, antiquated, in need of upgrade, how they're going to work, how they're going to respond to the pressures that are in front of us. And this is kind of an introduction to like, okay, like into thinking about nodes and systems and how a building you might build might have to participate in something like Carlos's waste system. Like maybe waste won't be handled by some obscure unknown thing that just once it exits the parking lot, like you just don't have to deal with it anymore. Like, and maybe a closed loop building isn't the solution either. Maybe there's some version in between that you know, becomes apparent.
I mean, I think it raises such an important question of data manipulation almost, right? Because I think the idea, this is something that a lot of students struggle with, especially in our unit, is that data have to be objective when, like, there's so much data out there. I think from 2008, I read it somewhere that every few days you would recreate the same amount of data that we accumulate as human race from like the beginning of time to 2000. And then that was being generated in a few days after 2008. So as long as you find a logical way to convince people that you have, a system, right? Because you cannot satisfy everyone. There's no way that you can use data in, the most objective way.
No.
So I think they can kind of take that burden off a little bit and almost kind of move on with their own narrative. So I really like these kind of bold moves because it's just testing their own idea, testing on the ground, and creating their own narrative. So yeah.
Yeah, I mean that was the first talk was world building. Like, what is world building like from a film and game standpoint, and how are we going to take that and like let's just kind of like play with this and speculate and just so we just finished the kind of research portion. I don't expect that we'll have as much of it in the end. It's more just to like get your foot in the ground. But also I think you make an excellent point, which is that like one of the things that we talked about was narrative versus disinformation. And I think it was Ning showed a bunch of like one of her talks showed a bunch of contradictory information about the same process and being like, okay, how do we as thinkers even navigate that space? Like when there is no way, you have to make a decision. How do you make those decisions? And I really hope that one thing that comes out of this, if nothing else, is like how to interrogate what you're reading, and also, yeah, how to relieve yourself of the burden sometimes when it's time to just kind of think wildly. It's a delicate little balance in there. Maybe we'll find it, maybe we won't.
Yeah, well, on the second project, I think there's an idea of technological sublime somehow embedded, because you started with your own impression and recognition about the infrastructure, its gigantic size and overwhelming propositions. And then you bring it to some energetic system, and then you bring it back to somehow to the local and social and economical structure of surroundings. I think you can, if you elaborate and integrate them, weave them all well, it would be an amazing project, I think.
Awesome, and agreed. It's also, we learned that Jeju Island already gets 40% of their energy from wind power because of its location and the fact that it's significantly better at wind generation than mainland Korea. So while it seems like a kind of crazy idea that he proposed, it is still based in reality and a game plan as the other projects are. So something I learned. Any other comments?
I have questions.
Mm-hmm.
Can you hear me?
Yes, of course.
Yes.
Oh wait,
you're mute. Jaewon, you're mute. You're mute.
Oh no.
Okay. I quite enjoyed the presentation so far, and then I saw a very interesting topic, and I have one question, and each student have a diagram which they designed in order to develop their project, and I think each diagram having some keyword or data set or some variable, and I think that keyword very important to deliver or apply for the cycle GAN experimentation, as far as I understand. So I think I wanna ask the tutor or student, is there any kind of relationship between some keyword from the diagram or cycle and machine learning data set for both? And second question is very quick question. And how would they work as a group after this mid-term review? Because each student having their own perspectives. So I just wondering how they work together as a group later on. Thank you.
Thank you. For the first question, how the technical diagram influences CycleGAN, it's in the research and the basic ideas around the numbers, sizing, scale, and location of the infrastructure that they're using. The technical diagram, or the diagram and how we're using it, will, I think, more specifically help with the second half of the workshop with using intelligent agents and scripting, because that's giving them the specific user that we're moving throughout the site, as well as how it's going to move through the system, and then what nodes it will interact with.
Okay.
But that comes after CycleGAN. And then, should I answer the
Okay, thank
question?
you. For that, I think thank you very much. And for that, I think the experiment, I think this is quite interesting experiment by using machine learning to develop infrastructure idea in the city. So I think by doing that, I think it should be specific, because it left only 2 or 3 days. So I really want to see how to connect between initial idea to some machine learning, some technology, in order to develop new kind of architecture, I think. So it should be specific. I think it doesn't need to be bigger idea or bigger scales. No. So yeah.
I think we both definitely agree with you. I think we're at a stage where we're at the biggest part of the project, because we still haven't narrowed down the exact users and the very specific element that we're focused on for every project. So I know we will be, though. And then at this stage with CycleGAN, we're still kind of figuring out how to manipulate those data sets in order to get something more specific. So it's very much in transition. But yes, that is definitely the goal, and something that we're talking about and thinking about a lot.
Yeah, so it could be fun. Yeah, so you know what, it could be fantastic. We wanna discuss later on, maybe final review, how we can find, or how we can discover the bridge between machine learning dataset idea and our initial conceptual idea. So it could be one of the very important issue we can discuss, I think, in the final presentation. Yeah.
Okay.
I think a lot of them kind of sort of in the background know, like we've talked about who their user is, or what that one single fine point inside their system is, but I don't think we just haven't gotten to like really push it through the system yet and see how it works. You know?
Yes.
I think the CycleGAN is probably the most complicated part of it, in relationship to learning how to get it to look right. And then I think I was going to answer your question about working together. It's kind of interesting because in a lot of ways, when a lot of the things we talked about when we first started on day one was that, no infrastructure system exists without touch points to the other. Like there's no way in which, Carlos's algae ponds won't in some respects interface with Ian's wastewater system. Like these aren't discrete systems, right? Like they're looking at them discretely, but on some level, it's all one site. Like there's no idea of this place. This place doesn't exist without energy, water, waste, delivery drivers, or so I think we'll start to see them come together. We have one that's kind of already starting to do that. The small nuclear reactors, where one person is really interested in the way we live around this infrastructure, like how do we live with these things, and the other person is interested in how do we get away from them when something goes bad, like how do we design for evacuation. So they're kind of already working the same idea, but just different angles. So I think there's a lot of space for them to come together.
Okay, thank you.
Are you gonna use the same site for all students, or some students maybe? because it'd be really interesting to see, like what you just said, like the city has got so much complicated systems, and we sometimes need to live with it without it or to avoid it. So it'd be really interesting to see how it works all together on one site, maybe.
I think
It doesn't have to be the all one site, but maybe some.
And I think in general, most are going to stick with the site. And Case and I have been talking about what that might look like if we overlaid all of them to see how that might interplay. We'll see. But
Okay.
yes, we've definitely been talking about that because I also think it would look cool. So, but then we also have some interests outside of the neighborhood I picked. So.
Yeah, I think there's an opportunity. We've been I think I mentioned it a little bit earlier about the about interpolation, using interpolation between the fixed stills to kind of create a moving image from this work. And I think there's probably some version going into editing software or using maybe even a StyleGAN AD8 to kind of blend them all together and get a, one of the things me and Laura do a lot is just continue to apply different machine learning algorithms on top of each other to see, that kind of copier effect of data as it gets passed through multiple lenses of abstraction, essentially, because I mean, if nothing else, to see whether or not we can turn data into information or abstraction, like where's the line in that space? And I think we'll push as hard as we can to get there. I think we'll get something fun. I mean, it's supposed to be fun in a lot of respects, I think.
Just one little thing to ask for Unit 3, because from social sort of architecture point of view, you'd be really interesting to see. I'd love to see how this system or this social network has been applied to this their urban fabric. So rather than students presenting all these beautiful images, maybe if they can describe quite in detail how those elements has been applied and how they got the result out of it for the final presentation. I mean, yeah, that would be really interesting so that we can discuss more about the social algorithm thing. Looking forward.
Okay.
Thank you.
Yeah, okay, no problem. You mean like how did the data sets get collected? How did they, like the process, you're talking about the process, right? Like how did we go through the process of even beginning to collect data? Like how do we even find it? And what do we do with it once we have it? Yeah, sure, no problem.
And will be much longer, so the students will have a better chance to explain their projects. That was my time constraints on them all today, so thank you.
We gave them 5 slides. This has got 5 slides.
No, it's also not to exhaust everybody.
Yeah.
It has been great. Yeah, thank you.
Thank you.
Awesome. Yeah, it's awesome directions, everybody. Yeah, I'm looking forward to the next stage. Yeah, and we can move on to Unit 4 now. And yeah, please, even if you have finished your presentation, please don't leave. Yeah, this session is all ours. Yeah, and at least we should catch up with 2 units per time. Okay.
Shall we have a 5-minute break before we start the Unit 4?
Yeah, that will be great. Yeah.
Yeah. Let's have just 5-minute break and it will start at 10:50.
Okay, yeah. Thank you all Unit 3 students and tutors. Yeah, it's been fantastic. Great. See you in 5 minutes.
Is everybody back?
Hello.
Do we have everyone?
Yes.
So let's get started.
Oh, excuse me.
That's you.
Yeah, I think we can move on.
Okay. Can I go on with the unit's brief presentation?
Yes, thank you.
The short introduction.
Yeah, a short introduction. So. So for Unit 4, our unit is called Sabotage Untypical Encounter. And it basically starts with the idea of the Crystal Palace as being the beginning of the kind of utilitarian architecture that also kind of went with industrial era. And the problem that it posed as kind of being the final, almost like the most evolved form of architecture that kind of limits itself to technology and functionality, and it kind of, by axing the past of all the variations that happened before, it limits also its evolutionary pathways that kind of almost grants more diversity for the future. So these are utilitarian architecture that kind of, so we kind of started the unit by defining typical architecture as a somewhat vague concept. So we wanted it to be something that really prevailed everywhere around the world, that kind of replaced vernacular cultural architecture. And we, by showing this kind of photography project by this Swiss photographer, where he goes around 32 different countries and photographs 32 different cities out the window, he basically sees the exact same view. So this is the vague definition of typical architecture, and we kind of ask students to define their own definition of typical architecture in the beginning of the workshop. And what we're trying to do is, so there had been different strands of kind of untypical architecture, which are which become untypical out of its own context, that has now narrowed down to homogeneous typical architecture. And we thought maybe kind of redeploying the idea of diversified evolution, as can be seen from Darwinian evolution tree, we could achieve something like this. Oh, sorry, something like this. So something that was homogenized, we're trying to re-diversify again, but using the help of Staugen. So what it will grant, as I hope, and this might be a bit of a push, is there'll be various future scenarios that would impose some limitations to architecture, and if it just went on its own trajectory of being quite a narrow functional utilitarian architecture that dominates, then it doesn't have many variations. It wouldn't have many variations that could actually survive after an impactful, say a disaster or future scenario. So that was our intention, to kind of like grow architectural resilience, right, through diversification. So what we started doing was, the students kind of collected 2 sets of data. So of untypical architecture and of typical architecture, but from a specific culture for untypical architecture, because otherwise the scope would be a bit too broad. And so for instance, for the data set collected for untypical architecture, and this is just like how we kind of worked image scraping and kind of running them through different image shape checks to put into StyleGAN, and then finally running them to kind of extract high attributes and dominant features of untypical architecture. And the exact same was done for typical architecture, the modern, what we just conveniently call modern architecture, but modern architecture in my mind is not exactly the same as typical architecture. And what we try to achieve, was it not? I think my screen stopped. Can you hear me? Can you hear me?
Yes.
Sorry, my screen stopped.
Frozen?
It's frozen. There's just another slide after this. Wait. Again. Oh yeah. So what we tried doing was kind of merging the DNAs of untypical architecture and typical architecture. So kind of dominant features extracted from both will be used to create new diversified design. And I think that the focal point for students was to kind of establish what features or like how they would want to collect data according to their own intention, what kind of design extractions they want to do from each data set, and how they would like to merge. So almost like the logic, so it's like a methodology of how they work through different data set using StyleGAN, this deep learning process, to finally come to some sort of design materialization. So I think most students prepared up until that point, and then will intend to kind of go further by not taking these images directly, but extracting what we think are useful from these, merged data set between kind of modern and traditional architectures, and create a design. Thank you.
Thank you. Shall I invite our students to present?
Yes. So we're gonna do the two teams, yeah, and then after that we're going to have a discussion session. So let's start with the team one. Are you ready?
We are team one, Jongbom and Anji from Unit4. Unit4's topic is sabotage on typical encounter to escape diversity and break away from the generalized typical architecture as we enter the modern era. We are trying to create diversity by combining the main characteristics of Hanok, a traditional Korean architectural style, with residential typical architecture. There are many characteristics of Hanok, but we consider the most important as follows. First one is semi-outer space. Hanok is not a direct connection between rooms, but rather through a semi-outer space. For example, Maru, Chungjeong, and Madang. In Hanok, there are scenes that seem to look at the space through a frame. The nature landscapes and frames seen through them overlap to form a layer of space. Unlike Hanok, in a residential typical architecture, all spaces are connected from the inside and everything is indoors. Also, unlike Hanok's consisting of layers, it consists of cells. The rooms are tightly attached like cells, and they organize meshes stick together. We use StyleGAN, a machine learning tool, to check the features we thought of and discover other features that we didn't think of. When we input the data about Hanok, we try to teach StyleGAN the layer, which is the most important characteristics of Hanok. We prepared photos of various scenes that can be seen depending on the frame. We focused on changing the scene's sense of depth and in the space, depending on the space standing position or the viewing position in the same space. As a result of learning Hanok photography in StyleGAN, we were able to confirm the space of Hanok consisting of overlapping layers as we intended. In particular, according to the characteristics of Hanok in many semi-external spaces, in the result of StyleGAN, the nature outside the space and the Hanok seem to be connected as one. For example, this photo, the giwa, the roof of Hanok, seems to be connected with the mountain. Looking at these results, we thought that the permission of the exterior landscape into the interior is another important feature that shows the layered characteristics of Hanok. In case of residential typical architecture, various photos such as the exterior and interior of the building were set as the data set. As a result, even though we used the photos taken from various views in StyleGAN as data, there were many results that consisted only of rooms and windows. This shows that the spaces of the current residential typical architecture, such as living rooms, and kitchens, consist of simple repetitions of cells. And interestingly, because of the exterior and interior photos of modern architecture were studied together, the layers like Hanok appeared even though there was no image of Hanok in the dataset. The interior and exterior of the original typical architecture are clearly separated, unlike the Hanok. However, when the interior and exterior of the space were hybridized, the boundary between interior and exterior became vague, and it had the same characteristics as Hanok. Through these results, we were able to discover the possibility of combining typical architecture with Hanok. Based on this thought, we prepared and combined data of Hanok and typical architecture in the same ratio, and then trained with StyleGAN. Then StyleGAN created hybrid images with continuity with nature inside and outside the building by adding layers of Hanok to the residential typical architecture as follows. And we classified the images according to the sequence of experience the space in order to effectively express the sense of space directly, felt by experiencing the layers of space and the building, which is the most important factors for us. The following is a video production of hybrid images according to the sequence.
Are you playing the? Were you playing the video?
Oh, sorry.
We only could see your PDF.
Now, can you see the video?
Yes, we can. Yeah.
Yes. addition, we thought that through this method, various combinations for a hybrid space could be made with countless data generated by StyleGAN. Until now, the residential architecture was layered through GAN. We will try to create a residential space with new diversity through the process of rearranging and intersecting these layers. This is end of the presentation. Thank you.
Hi, this is Tim Bree with Sungmo Kim and Soogyung Chun. I'll start to present. The impact of modernist ideologies was so great that the features of spaces are becoming more and more homogeneous. We sleep, eat, and work in a space that shares rather similar qualities to that of the rest of the world. Ever since the early 20th century, typical models of architecture were vastly spread and adopted as a way to improve the quality of built environment. But the problem arises when it eliminates the characteristic and the locality of architecture from various cultures in order to counter cultures. In order to counter such contextless imposition of modern architecture, its discourse should be sabotaged. We wanted to start investigating features that prevail throughout what we perceive as modern architecture, the traversing features. Likely, those of the local architecture, in our case, Korean Hanok, could be extracted. When collecting the data of Korean traditional architecture, we paid attention to the tectonics of Korean architecture that is made from the locally available materials and traditional architectures that were built within Korean territory, regardless of orders or programs. As for the counterpart, we focused on the modern interiors from early 20th century until today. Here, we would like to define modern architecture as being solely focused on the utilitarian aspects with its goal set on maximizing functionality and efficiency. To prevent any interference caused by the lack of spatial attributes, we had set up some principles for collecting images. Since the desired outcome of the experiment was to establish general design features from two sets, we try not to fixate ourselves on singular subsets of elements that might or might not correspond with one another. For the same reason, we avoided flat images or textures as they will distract the resulting space to have varying fields of depth. And lastly, black and white images not to blur any materiality. To extract the common features from both groups, we are using code-based machine learning program, and this will enable us to mitigate and generate attributes, generalized attributes. And then the high attributes extracted from two data sets will be paired and affect each other within the form of non-biased process. As a result, we expected the elements of both data sets to traverse freely between across elements and scale and compositions. The desired goal for such computer-assisted process, diversified pathways of evolution for architecture. Here we gathered every one of the new elements. We went through nearly thousands of images and noticed that there is a tendency to appearance when high attribute meets one another. We are only going to go through 4 elements as we only have limited time to present. We noticed that the way Hanok's materiality marries the modern interiors and its resilience to adapt without losing any of its components. If you look closely to the pictures on the left, you can see the wall made out of the clay and white elements came from the paper material in Hanok. Also, the curved space with Hanok's spatial quality inspires us to imagine the interior spaces of new kind. Madang is a Korean word call a courtyard of the house, and they were usually meant to be kept empty to embrace various activities. The interesting part is the changes on the compositions and the materials as opposed to its original. And it is now filled up with various patterns and patterns and materials collected from its counterpart. Corridor is not an element of Korean traditional architecture, but these images are showing us how Hanok's elements interact when it meets modern interior space and traverses its elements to be combined. Lastly, the categories of elements that we could not classify due to the fact that we don't have any categories for them. And we call them new types. The pure mutant, multiple story buildings with modern facade or exaggerated entrance with traditional components does not belong to neither of the data sets. Now we see the possibility of mutation and the starting point of our design. The next step would be generating a scenario or even a specific demand in order to bring acquired elements into use. And we will see if the design we develop from it can function as architecture and if that makes sense to people. Thank you.
Thank you. I will quickly share their images.
Can I ask a question, just so I have it clear in my head in the beginning before we also go through the other groups too? So the idea is each of these groups are creating their own data sets based on different areas of architecture or types of architecture, both interior and exterior. And then taking those data sets, running different style GANs on them, and then blending them kind of like in GANbrader in order to generate the mutation being like combinations of 2 to 4 of the style GANs from their initial data set. Is that?
So we didn't actually prescribe exactly how they would merge data sets from both like traditional housing and the modern housing. But what we made them do, or what we suggested, was that they should have some sort of intention in collecting the data so according to what kind of designs they want to achieve, what kind of features they want to extract, and how, like thinking of how they would do that, they collected their data, and we saw that as like a very important step. So kind of them showing a glimpse of the percentages and what they fixated on is, that's that, right? So that was not necessarily prescribed, and that's also part of their design process. So I think it would be helpful if you understood that as part of their design process. Yeah.
Yes, on data set creation and curation, we're all about it. So awesome.
Yeah, I also want to comment how well you described it, especially Sungwook, what you were categorizing and trying to understand these images from a human perspective. I think that is what you how you really go in there and collaborate with this machine, right? So I think that was really well done, and you did a fantastic job really trying to understand these imageries into some kind of architectural features. Yes, because if I just look at these images, probably some of them maybe doesn't really mean to me that much. Yeah, but you categorize it and try to explain it, and you understand it from your own eye. I think that is really valuable thing, that how you as a designer to take on from this can be meaningless images or meaningless data and really make it into a meaningful data. It's really a human's job, really. So I think you did a great job for explaining that, and it was a very interesting journey for me to understand these images. Yeah, through your presentation, through your eyes. Yeah. Thank you. And I really like the yeah, sorry.
No,
Yeah. Additionally, I really like the new types that said you could not really categorize them, and you said they are pure mutants, and I thought that word is like super cool. Yeah, that's something we are looking for, isn't it? I mean, I would love to look for those pure mutants and like uncategorized new types, and like really find some kind of aesthetic or architectural meaning of them. I think it's fantastic. Yeah, really interesting. Thank you.
Thanks for your comment.
Yeah, actually, our tutors, we have been trying to encourage students to have this concept of designing with artificial intelligence. We were trying to combine the computational imagination and human imagination, and we've been encouraging students to put some sort of humanity within the project. So yeah, as we are entering the second part of the workshop, maybe I think they can keep this main idea till the end of the project, I think.
And I'd just like to add that upon what was just said, it's exactly with this human creativity, right? That's also like the curatorial strategies that kind of comes with it. So, just although it seems like such, an objective thing like data, it's really not. And kind of learning, like students learning to use, the generative tool as really a tool, right? And understanding how to use it was such an important process. And I think because they had such intentions throughout, they were able to extract some design features at the end.
Okay, so I have a question in that point, and I think I really amazing and very interesting exercise. But I don't see any kind of meaning of what is a typical architecture so far. So are those exercises to achieve the meaning of what a typical architecture is, or just exercise? Just I would like to know.
So are you asking whether we have found what typical architecture to be, or?
Yes, so far, yes.
I think students defined what typical architecture is in their own minds. That is not necessarily just modern. It is something that incorporates both the utilitarian ideology and what they perceive as, quite typical everywhere in the world. But we have not put into words, but we thought it was really important thing to define, to move on to, some kind of mutations that have some evolutionary meaning, right? So yeah, is that an answer to your question? Sorry, I don't know if I answered it correctly.
But I understand it's difficult to say or answer it about those very theoretical thinking at this moment. But I think those are really good exercise in order to dig more interesting kind of composition or interesting some forms by using some machine learning. But I think, but your agenda is typical or untypical things. So I would like to discuss more about later on what is the meaning of those architecture things. You know, for instance, although we are some continuously repeat some column constantly, let's say, is it Hano or not? No, we don't know what it is exactly. But so in a way, I want to listen more about what is the untypical point of it, of your agenda or of your architectural some proposal later on from the Unit 4. So I think that's one of the kind of big question for me.
Yeah, I think it's really important not to kind of like for students not to perceive this tool as a literal tool to just generate designs, because understanding, you know, the implications of, you know, what they see as typical and untypical, and, you know, how like the designs that were design features that were yielded from it have, you know, certain implications. Yeah, I think, thank you for the a very insightful comment.
Thank you.
I'm thinking about that comment and what I'm looking at, and he asks like, is it an exercise or is there some, what do you do with it? And I guess is what I think I'm hearing. I mean, I'm not an architect, so you'll have to just bear with me, but like, what I think I'm looking at is an exercise in apophenia, right? Like in sort of laying bare the sort of artifice of is it architecture or not, by showing the kind of way in which we all find the pattern that we want to find in that space. And it's like a perfect example of that. Like it's a pattern misrecognition through a pattern recognition software, which I think is, is it Hano or is it not? It's like, is Hano even Hano? Like, how do you even make that distinction when I think you were talking about the floods of data, 40 terabytes an hour for an electric car kind of thing. Like, it's a great representation in an architectural space of the idea of pattern recognition and how it lays bare that impulse on every level of us as humans, because we're talking about bringing a human aspect to it, but it's not a human. Humans picked it, but it doesn't have its relationship to image making is so wholly unhuman. Like, that's kind of the whole point, right? Like, it isn't any of those things. It's its own thing. I don't think it pretends to be architecture at all. I mean, that's just my opinion, of course, but
I think.
Sorry. I was just gonna say, also has to do with it being in 2D versus 3D. Like, obviously architecture, we experience this in a 3D way, we experience the space within it. Whereas with like 90% of machine learning algorithms right now, like, we're in the 2D space. Everything image-based, it's all 2D. So I think in flattening that, yeah. I would also be curious to see if you ran an image classifier at the end of this, to see like what percentage the machine thinks of each of these images is related to, like, so just to see what it would say, 30%,
You could train one on both your architectural types and then run them back through it and see whether or not it thinks it's making what it thinks it made. It's like you can get really meta with it. That'd be fun.
But I think that kind of like the percentage of what went in and what came out is almost not important for us, because what's important is from now on how the students will extract what they think are the starting points for new designs, right? So this is not a literal tool. It's more of a methodological experiment, whether it'll be a viable a design making, it could be whether it could be a viable design making tool, or how it could be used as a design making tool. So I completely agree with the 2D 3D dimension thing, because that was also quite talked about in the unit, but it's just something that we will have to slowly figure out, right? It's
yeah, I mean, that's,
one.
yeah, it's hard. I mean, it's a pretty well-trodden approach to design, like especially like in the fields of molecular biology, using machine learning to generate thousands of iterations, and then using another machine learning to find out whether like some sort of greedy algorithm to see whether or not they've optimized the structure at that level. I think it's really a cool way to like begin the process. I think it's pretty slick.
Yeah, actually, in terms of the dimensionality, I think even though we are seeing the 3D, the object in our eyes, but the perception of these eyes is actually the projection in the 2 dimensions. And then when we use the 3D, the modeling software in computer, but actually what we are seeing in the monitor is actually 2D, but we can feel the 3D like a feeling. So what I wanted, that's because there are like the several features it makes us feel the 3 dimensionality, like the contrast or some different the brightness. So yeah, actually we should admit that it's not actually the 3 dimensional the stuff, but in some way I would like to say we could also make the point that we could perceive it as the 3D space 3D spatial quality.
Yeah, I mean, I would argue it's not even 2D. I would argue that it's just a mathematical calculation of pixels that we interpret as being 2D, but it really, I would contend that it's a list, that it's a list stored in computer memory, right? Like, I mean, so I think there's a lot of levels. I think that's why we're talking about it in that way, that like there's something very interesting about the play of the vision of the machine and the human element that's being brought to it, and understanding that interplay is probably got some sort of lesson for architecture that I don't know, but someone probably does, and I don't have no idea what it is.
Cool, thank you. We have more projects coming, right? So maybe we can move on. Yeah, we will continue this conversation, I'm sure.
Yep, let's move on. Okay, next
Well
thing,
done.
team 2.
Thank you.
Thank you. Thank you for the conversation as well. And team 2, are you ready? All right.
The first picture show a vertical boundary, and second picture show a visual boundary, and the third picture show a boundary using the sunlight. One of the features of the traditional architects is that is a broad boundaries, and one of the features of a modern architecture is that they are created across spaces. The floor of a Korean veranda blurs the boundary between the inside and the outside. The corridor separates the space and become the standard for the dividing boundary. LDK become a closer space by creating LDK become a closer space by creating a wall as shown the figure. When the boundary is a clear same, the personality can be acted in one space, but when boundary is ambiguous, behavior with different personality can be performed in the same space. When I thought about the elements that blur the boundary in traditional architecture, I thought that there were a pedestal and the floor, and the elements that make a closed space in modern architecture are the hallway, LDK, and veranda.
With the AI deep learning in the style game, we found new elements as well as recognized elements and the trained AI. Traditional architects has two characteristics in one space as personality recognized and the separation of the spaces stands out in the modern architecture. The following image is the result of the modeling using a style game to create a data set by combining elements of traditional architects and modern architects. As I look at the image, I thought that the elements of the traditional architects and modern architects will combine to blow in the boundaries. There were three elements: future, furniture steps and the floor pattern. The red border is the furniture elements, and the blue border is the floor pattern elements, and the yellow border is the step elements. The three images next to each other are images extracted from the three trained image furniture step difference and flow pattern using the image generator function in style game. First, explain the change of the flow pattern and the arrange of the furniture, which elements the separated two dimension space physically change are caused by the change of the flow pattern. In addition, it was found the furniture is a section that causes the ambiguous boundaries according to the arrange of the furniture. And the level difference, which is a three-dimensional separation, causes various loss and ambiguity of the boundary, and classified as follows. The flow pattern is the furniture elements where the two of these the elements below the boundaries when two characters with one space, and while looking at the image of the level difference images elements, I thought that the three dimensional senses of the space were clear and the boundary were vague due to the various level difference. Ambiguous of boundaries when the level different and low within the different insights that can be used by the discovered on the Korean veranda obscures of the boundary of the couple with the two personality in one space. The ambiguous of the boundary when level difference of the large within with there is a large different level in the building. There is a huge space connected to the skip floor and atrium, and to space with different floors, and the different personality will be commit, and the boundary will blow. Ambiguous of the boundaries when the external level difference of close parts that have an environment where which people can believe, such as a terrace and the Korean terrace, that face the outer space of crossing the boundaries between the outer space and the building. And this video is our concept video made in style game. Thank you.
Team 4. Yep.
Hello, we are Hyung-Seop Seon from Unit 4. And our team decided to define typical architecture as a universalism. Let me ask you some questions. How can we represent different cultures? How is one culture different from another? And is it necessary for specific culture to sustain its high attributes throughout? According to Edward Said, Orientalism, the East and West have always been dualized, and the West has come to impose dominant systems of modern knowledge and cultural attributes with humanism and universalism that developed from the Age of Enlightenment. The dualism necessarily led to one party being dominant over the other, and many attempts to reverse such a tendency had failed. So in order to implement post-Orientalism, to reject this ever-polarizing model of dualism, we would like to suggest post-Orientalism, a new method of understanding the world based on harmony rather than dominance and differences. To implement post-Orientalism, forming new relationship between Western typical architecture, modern building, and local untypical architecture, Hano, will be vital. New relationships between these two architectures could develop in attributes, differences, and uncertainties, and could possibly be used to deviate architecture from the existing framework. We thought that StyleGAN was a perfect tool to establish these new relationships between typical architecture. First, we are interested in void to capture the universalism and create new relationships. We have collected 3 sets images, those of organic Hanok Street, modern Seoul Street, and modern interior. As a result, we noticed that urban situations start occurring inside the Hanok. Let me give you a second example. The racehorse and the pack horse are of the same species, but the pack horse is more similar to a cow. Different species could have a region of homology in their genetic pool. We proceeded with StyleGAN by capturing the homology across wood and concrete, materials native to Hanok and typical architecture, respectively, when used as a structural element. Our supposition was that wood and concrete would complement each other. As a result, we found the possibility of concrete working as a structural open framework that could embed flexible wooden structures within. This was done in the same way by collecting data sets to see only the inside. Therefore, we discovered the possibility of Hanok that captures urban situations through hybrids of wood and concrete. I can imagine Hanok City streets, Hanok vertical city, Hanok vertical city interior. So I'd like to finish the presentation with my video.
Okay, just give me a second. I will share the screen with your images. Now I'm capturing it, so sometimes I need a moment.
This is not really a comment about the project for the one of the last images we saw, but more just something that happens with StyleGAN that I find very like dystopian and quite scary. And like when a lot of these images tend to like it's like the over homogenization of an image. So then everything, all the architecture that ends up coming out of it looks the same or so similar, no matter what you put into it. Some of that is because the strength of certain parts of the data set tend to like overpower the rest of it. But as like a proposition for architecture, I'm always like, that's terrifying that everything looks the same. But I mean, that's just what happens with StyleGAN too sometimes. But I think the more interesting question or like comment that I have was in like one of the first group's images, they were showing various interiors, and one of them was a hospital interior versus either a home or an apartment, like corridor versus a living room. And the importance of creating a data set that you kind of want to recreate, that you want to generate more of. And it's like, why are we picking these initial images? And it's to create more of those or blend with those styles. And so I find it really interesting to pick like a hospital corridor, something that isn't often chosen for its aesthetic reasons, but more for the necessity of having it be a certain dimension. This isn't really like a comment about the project, more just like, these are interesting things that I found with the two. Maybe my comment is more just like, what do you think about that? Or do you find that frustrating? Or are you like, yes, we want all of the architecture to look like concrete with CLT beams and like scaffolding on the outside?
I think some of the choices that students made in collecting the images is that I think they had some speculations on, you know, what attributes that these typical architecture have, right? And what attributes that, you know, traditional Korean architects have and architecture has. And I think it's almost like a confirming sometimes it's used to confirm what you believe in, and sometimes it kind of gives you a completely new, you know, like an object, like a more less biased outcome, which I thought was quite interesting.
That's why I thought the hospital corridor was such an interesting choice to add, because it's like something I just didn't expect it for as a student choice. And so I was like, that's interesting. Like, I want to see what comes out of blending those together, kind of.
My question is, you gather an initial data step through what, like a keyword scrape? Like, do you use a keyword scrape to build to grab the aggregated data set, and then you go in and pick through the ones you want? Like, is that?
Yeah,
so,
exactly.
So, yeah, so there's almost like, you know, it's almost propagating forward the logic of the platform from which, or the API from which you can even access the original data scrape, right? Like, there's all these kinds of built-in layers. So like Laura's saying, I think it's interesting to make that choice. And then you're kind of like, well, how much of that choice is made by people who are labeling their pictures for the Pinterest scrape, you know, back at the front end? Like how does all the kind of layers of intermediaries that are controlling, you know, the data set creation, so that we have this kind of idea that we're curating this data, but the API is kind of curating this data? Because like, maybe you can't, does that make sense? Like, I mean, I have this problem with natural language processing all the time, which is typically done through scraping, you know, like, certain places I can't get their data, or depending on how people choose to label their data when I go out looking for it, foregrounds certain aesthetics or foregrounds certain ideas and builds in, again, I use the word like this apophenic kind of thing where you think you're getting a certain type of pattern, but you're really not. I mean, the analysis of that is really interesting to me as well. Like, if you did this 10 years from now, when you scrape modern interiors, you might get something completely different under what's considered modern, because the word modern, which is a key, which isn't just a conceptual choice, it's baked into the very process as a labeling process within the way the back end is aggregating these images for you. So like, there's a super interesting temporal aspect to all this as well. Like if you did this project 10 years from now, using the exact same keywords, you might have a completely different style GAN, which I don't know if that's useful. But when we talk a lot about data set creation in our, I mean, we're talking about machine learning. So obviously data set creation is the main thing we talk about. And I'm always interested in unknown biases and different ways in which I'm getting tricked into thinking I'm making a choice that I'm not making at all. And I just wonder, like, that and I only have one other question, which is hey, you know what? Never mind. Really cool though.
I mean, I don't, okay, sorry. Could you, in 1 or 2 sentences, summarize your, it was like a really long one. And, it had quite a lot of like layers to the question.
Well, that's sort of the point, right? My point is how do you, we say that we're making these decisions about, we say we're curating this data set, but how much, I mean, really curious, how much are we actually curating this data set? Like when we look at our projects, those data sets maybe are curated, I mean, first of all, Google, if you're Google image searching, Google is curating those things for you. If you're doing a scrape, you're going out and looking for keywords on Pinterest or somewhere, right? Like, so those people are, depending on how they label these things, are sort of, they're constraining the ability of you to look for what you even want to look. I mean, this is the biggest problem in data in general, right? Labeling. So I'm curious how you think about that, or how you deal with that when you're making these selections. And I use the example of the word modern, because obviously, like, if I want to mix a modern, if I want to look for a modern interior, because the guy brought up Orientalism, and I was just very interested, like, in that, how you guys reconcile that through the process. Like, how do you know that you're getting a modern interior? Like, I don't know, through the technological, it's being mediated by so many layers of technology.
I mean, I think, okay, my personal belief is that when you start collecting a data, like collecting data to create a set, you are not really engaging in the process that is super objective. I think it's super subjective. And even when we did image scraping, we asked students to kind of really go into the images, pick out the ones they don't like, pick out the things that would distract them from kind of obtaining images that they wouldn't want, in a way. So we kind of tried to actually remove quite a lot of unpredictability, but obviously we knew that StarGAN will give us plenty of it anyhow. So we wanted to kind of limit that as much as possible. But it's interesting because I really think dataset is just really used to kind of support your argument rather than reflect what is true. And I think you have to often kind of collect data from so many different organizations, and they're not categorized in the same way. So it really, I mean, I think it's really, it really depends on your subjectivity. And I think that there's beauty in that. I think that in itself is, one of the most essential parts of the designing process, when involving big stuff.
And also, I think I totally agree with the cases comment, actually. And also, I think the data set has to be designed for this project, I think, because there are so many different types of different photos of Hanok, for instance. For example, Hanok from Joseon Dynasty, Hanok from modern era in Seoul. So many sizes or types of Hanok we can discover and you can find from the images. So I think the data set should be a little bit more specific in order to make some sharper argument or proposal. Yeah.
Yeah, I agree, and I think these comments are really important. I know, like maybe for this short workshop, maybe you cannot really like kind of make a very clear selections of what these different keywords and search engines relating to also search keywords are going to give you like more specific results. This is another science, I think, but at least the students should really aware that when you input certain keyword and the result that is returning has to be very critically evaluated or critically understood instead of just accepting them. That's in that terms, I think it's really, really valid comment. And of course, we cannot really evaluate if the resulting sets of images are actually representing what you want to say about certain styles or certain keywords, such as Hanok or what was the word? Orientalism. Yeah. So like Orientalism can be understood in such a different broad ways, and the way you are downloading these images currently is depending on some people. Maybe it's very randomly labeling their own images. So you should not just accept it and believe it. What people saying that it's a certain thing is what you should just believe in it. But you should be able to really curate what you can download and work with this technology. Yeah, I think searching and labeling, you have to understand that it's very random and it doesn't have to be always very accurate. Yeah.
Yeah. Also, I totally agree with that. We couldn't avoid the bias. Every like data collection requires some that kinds of the bias. For example, like even people or even some of the machine like, and then so one possibility to utilize it is kinds of the understand some the signifier and the signify words kinds of. So what we want to try to do as a like the additional step is that when we type some the keyword, every people imagine some of the different kinds of the imagination, and then but we could collect all that kinds of stuff from the like the hashtag searching in Instagram, and then I believe it could be some the other the possibility to investigate on like what people thinking about in their the memory in some certain word as the visual the stuff.
Yeah, I wasn't trying to like make a I'm just always interested in like even the platform itself. Like I mean sometimes I don't think it's random. Sometimes I mean I'm kind of on the opposite side where I'm like, no, I think access to certain things is not random at all and highly proprietary, and that like a lot of one of the things I find is that a lot of our research coming from the areas of academia are kind of limited because we can't get at like large, well articulated data sets. Like we're forced to kind of cobble them together through, you know, different, like I just think about the difference I see in images like this from back when you could still grab Flickr. Like there's been a fundamental shift in the type of images you can get when they took self-described professional photographers, you know, 15 years of work and cut off access to the scraping of Flickr. So like there's like a whole political element to how the platforms that we take this image data from is being mediated for us. And I don't think that that has anything to do, I guess, with the project directly, but I just think it's like a fun thing to think about as we like journey through the process of, you know, bashing images together, you know, and seeing what happens. That's all I was trying to get at.
Yeah, so I feel like what I wanted to force the student is like the human intervention at the last stage. So by doing that, they could put the intention, even though it's like it already have some of the bias. So I believe it could filter it. It couldn't totally, but it some sort of, yeah. So yeah, it could be some the solution to avoid some the very skewed, yeah, bias.
I mean, you saw our project, so like, don't worry about it. Like, I'm not pointing fingers, man. I just think it's an interesting idea.
Oh, it's a good conversation.
Yeah, I mean, we also be aware about this this conversation as well, because we also discussed about exactly the same thing about yesterday. So, and then I believe that one of our next team is going to bring this issue, because we were exactly discussing about the difference in between the keyword and what they were thinking. So I hope they still have that in their presentation. Yeah, so I think we can move on to the next team, and then let's see the how they bring these issues. All right.
Okay.
So yeah, team 5, are you ready?
Yes, I'm ready.
Cool. Share your screen and go ahead, please.
Hello, we are Hyunji Kim and Hyunwoo Kim from Unit3. We are going to present our project on typical landmark. If you look out the window, you can see similar buildings except for some of the representative buildings in the area. Like this, the buildings around us all becoming typical architectural. How would you imagine an architectural of a specific culture? To gain insight into this, we propose a contextless metaverse of 2031 World Expo, where architecture's different countries bring out distinctive their features. How can we distinguish a country by building? Because freeform buildings carry landmark-like features, we wanted to design representative Korean buildings as such. However, if you observe them all at once, they are often seen as typical buildings because they often omit locality that have been part of their context for a long time. Locality comes from tradition. Local buildings, too, should incorporate locality through the traditional features that evolve over time. When we think about the traditional Korean architecture, we think of Hanok. In this project, we want to sabotage the typical architecture by merging the curves of the freeform building and Hanok. Going back to building the Korean pavilion at the 2031 Expo of the Metaverse, we would like to propose a new generative method. We would like extract landmark-like features from freeform buildings while retaining local features of Korean architecture using the AI called StyleGuide.
We prepare data set A, B, and C. A is 1,000 Hanok pixels. B is 1,000 pixels of freeform buildings, and C is 2,000 pixels plus A and B. We thought that if we provided AI with pictures taken from various distances and perspectives as input, we extract pictures that embedded new design without human bias. This is how we created the dataset for StyleGAN. So the all dataset which are input to StyleGAN are composed of photos taken in this way.
This picture is one of the results. This part is derived from a close-up picture of left of the Hanok housing, and the overall shape is derived from the elevation of freight home building. Therefore, various scales are mixed in the picture. This is the result of the combined form of the raster from the bottom with the overall shape of the freeform building's elevation. It's like cubism, which expresses the form from different angles. We thought it would be interesting to apply the difference in varying scale and perspective to design the said Korean pavilion in the multiverse. The noticeable picture that we observe from the output are as follows. First, as you can see, the style of Hanok consisting of column, floor, and roof is repeated, creating large grid. Second, as you can see in Hanok, constructing shape of light appear due to the varying structural composition of the unit member. This is later combined with a grid of freeform building in a hybrid output, yielding it a sense of bumpy characteristic. Sometimes the roof was stacked in 2 or 3 layers. Several Hanok houses was stacked in multiple directions. Dominant picture extracted from the Hanok dataset can also be observed in the result of the hybrid dataset. This form of freeform building output affects the hybrid output. Therefore, these forms were created by combining the raster structure of the Hanok. In conclusion, we would like to present the design of our own untypical architecture in the contact-less multiverse, reflecting the marriage of fixture extracted from typical free-form building and those that reflect the locality of Korean architecture. Thank you.
Thank you.
And please go ahead, Team 6. Sangyeon?
Yes.
Yeah, please go ahead.
Hello, we are Yoo So-hee and Kim Sang-yeon from Unit3. There are many countries in the world and each country having its own culture and history. We thought the street was the place where the untypical characteristics were most visible. There are many countries and cities in the world, and each country has its own culture and history depending on its surroundings. In other words, they're untypical in themselves. As many people pass by, we think the streets that show various aspects are the place that can maximize the untypicalness. However, many things have been shared by the world community, and cities in most countries have been made similar. Currently, globalization is dominated by Western and practical cultures. When researching image, we found European apartments are natural, and our country is also building rectangular high-rise apartments nationwide, which value more personal interior space. More and more cities are appealing as typical, like Kobakud. I questioned globalization in this direction and thought about other direction. We would like to use Tarzan to solve this problem. The cultural, historical, and social elements of each city in street were separated and advertised and reassembled through the program. In one way, the cultural, historical, and social factor in street that each city has a vectorial input, a single image. When I post street photo of each city, the output was as follows. In conclusion, when street photographs of each country were put and styled, images of diverse cultures and history came out. And in this way, new aspects of globalization city were created. Through this, I thought it would be interesting to design a simple city. In addition to this, I did another experiment because I thought it would be interesting to collaborate with the ununified feature of Hanok on the streets of its country. As follows, we put pictures of city streets and Hanok Street around the world. The results were as follows. These are the most interesting picture of outputs. The first photo shows that height of the Hanok growing like a building and harmonized with a large building in the background. In the second picture, there are Hanok eaves on the grid of the building and a building behind the Hanok in the third. The first is also one-story Hanok building with a skyscraper in the background. In conclusion, it is interesting to collaborate with cities around the world and Korea. From this experiment, we will come to the following conclusion, and I think we should take this to conclusion and plan the city to the confidential closing. Thank you.
Can I just say quickly that I really like this idea of like taking existing tourist destinations or landmarks and trying to like design new ones or generate new ones, because then you can think about like how the city might be like, we need more tourism in this new area we just built. What do we need it to look like? Like, you know, I could definitely see this playing out, and I think it's really fun.
It's GAN-based urban market research. I mean, I think this one is really provocative. Like, I would be really interested to see some of these images, like this one down here. I'd love to see that, like, know what these things are, you know? Like, I mean, it's like, as someone who's generally who works in speculation and world building, I'm like, oh, this is like such a primer for like thinking a little bit and being like, what are those things? What are they, multi-directional elevators? What are they doing? Like, why are there all these green spaces all over the place? Like, is that some sort of new version of underwater or underground stormwater runoff, like drainage system? Like, I just see this and go like, it's just provocative, which I think is one of the best things about GANs, you know, is I go back to that apophenia thing. Like, it gives me an opportunity to project myself into it and then speculate based on it, since it is so wholly unknown. And it doesn't propose to be something other than the unknown, which I really like.
Yeah, that's also like interesting point. So it's kind of like generating some unexpected mutation using GAN.
Yeah, I mean, you know, which we all know GANs can do. I mean, that's sort of what they do. So the question becomes like, when they generate that, because like, you know, when they make that mutation, like us coming back and applying the narrative to it and saying like, well, that's not just some random, you know, RBG value being substituted for another RBG value by a you know, a set of weighted if-else statements, but it's actually this hyper designed like vertical transport system for a overly densified core or something. Like, then you're just like, oh, great. Like it's like a thought starter, you know?
It's almost like the, you know, how surrealist painters, right, extracted their ideas from their dreams, like from their subconscious, and I think what's quite important, I mean, it almost works in the exact same way, because StarGAN is fed with data that has some sort of meaning. It does its own thing, creates this like, random, not random features, and we interpret them through our own eyes.
Yeah, and I think this one's pretty cool. There's just something really gets me about the cityscapes. I don't know. Maybe I just work with cities too much.
Yeah, so one experiment we want to try to do in this workshop is to enrich the architect, designer using this technology. So by using it, it might generate some, the unexpected stuff that gives them the idea, new idea, or some, but it's gonna be like very weird approach in the architect's perspective. But this new approach, I believe, could perforate the academic, the architecture field. So that's kind of like some of the possibility we want to try to get.
Yeah, to me, it is like this procedure gives us some sort of like knife eyes somehow with its unexpected result.
Yeah, I mean, I think there's a pretty heavy practice of that right now, where we are with using these tools to generate, especially like, because, you know, like I work in film, and we use these tools to do exactly that, to think like, you know, we're constantly regurgitating the same images over and over again, because that's sort of what Hollywood does. That's like it's stock and trade. So we use tools like this to throw things together, to spark some ideas about how we might make, because we need to make like 40 future cities every week. You know, we need to like reinvent everything. And so I think it's interesting to see it applied in the academic sphere, where there's a little bit more rigor necessary to like justify. It's not just a backdrop to some story, it is the story. And so like, I start to think about like how it could, you know, how it could mutate into, that's it. I just want to use the word mutate. I don't have anything else to say.
And in that regard, I think it was quite nice that Team 5 chose a contextless kind of like a setting of their own to test this, you know, idea, right? Because it's just I think that almost adds, you know, another layer of interpretation to their process.
Yeah, I mean, oh yeah. I mean, I think this one is like extremely provocative. This one right here is like, I don't know why, but I just find it like, and the one above it as well. Both of these, they speak to me like in a way that makes me think of a story of a person or the people that might be in this place. And it has like, somehow or another, it's managed to kind of age and take on a patina. And this I think is a feat, no small feat in generative, what we call synthetic media or generative art, right? Like just architecture aside, it's like getting that image is pretty slick, you know, it's good work. Like I like it, you know, it also sits in this nether world that really kind of speaks to me. I think both of these are really pretty hot.
For the comments. I mean, is there any more comments from anyone? This was the last presentation, so.
Yeah, I think they are really interesting, really well done. And I think every single presentation was really, really inspiring. Yeah, thank you everybody for all of your sharing and your input, hard work for getting all the presentations done in this quality today. Yeah, really appreciate. Yeah, and looking forward. Please, everybody, remember to upload your PDFs to our shared Google Drive. Yeah, we have to archive your work, and we might have some future publications when we will try to promote everybody's work. Yeah, and have more audiences. Yeah, and we will have another session in the afternoon, 2 o'clock, is it? Or what time?
Is it 4, I think, 4 p.m.
4
4 p.m. in Korean time.
4 p.m. Yeah, and we encourage all the students to join in if you don't have too much problem with time difference. Yeah, just join in and check out what other students are up to. Yeah, and yeah, we really appreciate everybody's input. Thank you so much. Really looking forward to your final product.
Thank you.
Yeah, well done.
Good job. Oh, good job.
Good job.
Well done. See you around again. Yeah. Thank you.
All right.
Thank you.